Hello everyone, this is Dr. Webb. So in this video we're going to be talking about another rule for taking derivatives called the chain rule. But first let's review the rules that we've seen so far. So first of all, if we're taking the derivative of a constant times a function, well, we can just pull the constant out and just multiply the constant by the derivative of the function. And so the derivative of a constant times a function is the constant times the derivative. If we're taking the derivative of a sum of functions, that's equal to the sum of the derivatives. Then the two rules that we saw in the last video. So first, if we're taking the derivative of a product of two functions, it's not quite just the product of the derivatives. It's more complicated than that. It's the derivative of the first times the second plus the first times the derivative of the second. And then lastly, we saw the power rule, and it's if you want to take the derivative of x to the n, you're going to get n times x to the n minus 1. And so we've shown that to be true for integers so far. So the focus of this video is how we take derivatives of compositions of functions. So really we're thinking about taking the derivative of where we have some function g of x which is stuck into another function f of x. So let's start playing around with this by doing an example. Okay, so we're going to try and take the derivative of 1 over x squared plus 3. So first, let's think about how this is set up as a composition. Right? So what is the inside function here, and what is the outside function? So I want to think about this as being the derivative of f of g of x, where g of x, this is playing the role of our inside function, and f of x is playing the role of our outside function. Okay. So what's the inside function here? And what's the outside function? Well, we have 1 over x squared plus 3. Okay, and so we can think about the 1 over as being the outside function. And so the outside function would be 1 over x. That's the function that takes reciprocals of things. And then our inside function is what's in the denominator. That's x squared plus 3. And so that makes this equal to derivative of f of g of x. Okay, so now let's work on taking the derivative. So the only thing that we have really to play around with this so far is the definition of derivative. So let's start off with that. So it's a limit. We're going to be using delta x going to 0 as being what we're taking the limit of. And so then we're plugging in x plus delta x to get f of x plus delta x. And so that would be 1 over x plus delta x squared plus 3, and then subtracting off x squared plus 3 all over delta x. Now we've got fractions inside of fractions, and so we want to cancel these off. And so we're going to multiply the top and the bottom by the denominators on the bottom. And so this is going to be x plus delta x squared plus 3 times x squared plus 3. And then we're multiplying the same thing down on the bottom. Okay, and so when we do this out, on the top, the x squared plus delta x squared plus 3, that's going to cancel off and leave an x squared plus 3. And then minus the x squared plus 3's are going to cancel off, and we have x plus delta x squared plus 3. And so there we have it. Okay, now what can we do here? Well, it looks like the main thing we can do is expand that quadratic in there. That should be a delta x there. So let's expand that out. And here it is expanded out. And now if we distribute the minus sign right here, minus, 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 well, we see that we have an x squared and a minus x squared, and so those are going to cancel. We have a plus 3 and a minus 3, so those are going to cancel. And so here it was, and so again, the ones that are going to cancel is the x squareds, the plus 3s, and then we have a minus there and a minus there when we distribute it. And so that simplifies down to this. Now we notice that each term on top have at least one power of delta x, and there's the delta x on the bottom, and so at this point we can cancel off a delta x everywhere. And we're left with minus 2x minus delta x on the top, and then on the bottom we still have the product of the original denominators, x plus delta x squared plus 3 times x squared plus 3. Now there's no problem with letting delta x go to 0. So at this point we can apply the limit and let delta x go to 0. And we end up with minus 2x plus 0 over x plus 0 squared plus 3 squared. So these two terms in the denominator are the same. And so we can simplify that just to be x squared plus 3 squared. And so our final answer is the derivative of 1 over x squared plus 3 is equal to minus 2x over x squared plus 3 squared. Okay, so let's think about this back in terms of this function as being a composition. And so remember, our outside function was f of x, that's 1 over x, and our inside function was x squared plus 3. What are the derivatives of both of these? Well, we've done the derivative of 1 over x before. In fact, we can use the power rule for this, and that's minus 1 over x squared. And then the derivative for x squared plus 3, well, it's the derivative of x squared is going to be 2x by the power rule. And then the plus 3, that's a constant, and so it just disappears. So g prime is equal to just 2x. Now let's see where these parts seem to be fitting into our answer for the derivative. Well, so I've got g prime is 2x, and I see a 2x right there. My g of x is x squared plus 3, and I've got x squared plus 3 right there. Now what's left is I have a minus on top, and then I'm squaring stuff on the bottom. Well, that's exactly what's happening in f prime. And so what this looks like is that g of x is getting plugged into f prime, and then we have this factor of g prime of x being multiplied to the whole thing. So what I'm saying is we can think about this as being minus 1 over x squared plus 3, quantity squared, then getting multiplied by 2x. And so this is g prime of x, and then this term right here, there's g of x right there, and it's getting plugged into f prime. And so this is f prime with g of x plugged into it. Okay. So there's our derivative, and we said we can think about it as being f prime with g of x plugged in and then multiplied by the derivative of the inside, g prime of x. And it turns out that this is always how taking derivatives of compositions of functions work out. So this is the general rule. This is what we're going to call the chain rule. Okay, so let's see how this works in general. And we're going to go about this the same way that we did before. So we're trying to take the derivative of f of g of x. So we're going to use our derivative definition. And so we have g of x plus delta x plugged into f, and then minus g of x plugged into f, and then all divided by delta x. Now the trick that we're going to do here is that we're going to and this is something we've done before, we're going to think about g of x plus delta x as being g of x plus some change g. Okay, and so in this case, delta g, another way to think about this is that we're setting delta g to be the difference between g of x plus delta x minus g of x. So it really is measuring the difference between the two, or the change between the two. Okay, and so then we have that written nicely right there. And so now the trick that we're going to do is, so for the product rule, I said there was two tricks that mathematicians use, either multiply by 1 or add by 0. And to do the product rule, we added by 0. For the quotient rule, we're actually going to multiply by 1 in a clever way. And the clever way that we're going to multiply by 1 is going to revolve around this delta g, this change in g. Okay, so we're going to multiply delta g to the top and the bottom. Okay, and then what we're going to do is we're going to really keep these fractions, but swap the two denominators here. Okay, and we're allowed to do this because they're getting multiplied together. And so we're going to rewrite this with the two denominators swapped. What's nice about doing this is now we have this delta g over delta x. As we take delta x going to 0, this is going to become g prime of x. So this is the g prime of x that's getting multiplied at the end. And then what we have when we have left over is it's g of x plus delta g minus f of g of x all over delta g. Well, and we're taking this as delta x goes to 0. Well, one thing to note is that delta x going to 0, this is exactly the same thing. This means that delta g is going to 0, right? Because g is differentiable, and so it's continuous. And so as delta x goes to 0, the difference between the g's is also going to 0. And so this right now is looking similar to the definition of derivative, just instead of x being plugged in, it's g of x being plugged in. And delta g is playing the role of delta x here. Right? And so when we break this up, as we said before, this limit on the right, this is g prime of x. And then this limit on the left, it looks like the definition of the derivative of f of x, but instead of plugging in x here, we're plugging in g and delta g's, and so this is going to be f prime of g of x. Okay, and so we end up with what we saw before. The derivative of f of g of x is equal to f prime g of x times g prime of x. Okay, so here is our chain rule. Derivative of f of g of x is equal to f prime g of x times g prime of x. So this is f is our outside function. G is our inside function. And so the way to think about this is the derivative of the outside with the inside plugged in times the derivative of the inside function. Okay, so let's finish off this video by doing an example. We're going to take the derivative of x squared plus 3x plus 1 raised to the 102nd power. Now, if you want, you could just expand this out, multiply this to itself 102 times. You are perfectly welcome to do that. It might take you a while, but I'm going to, if you want to do it that way, that's perfectly fine. I will let you do that. You can pause the video at this point and come back in a couple hours when you're done. On the other hand, I'm going to do this using the chain rule. So how can we break this up? How can we think about this as being f of g of x? So we need to think about what our outside function is and what our inside function is. And so f, our outside function, well, the quadratic on the inside is being raised to the 102nd power. So our outside function can be x to the 102nd. Then our inside function is going to be the quadratic. Now we need to know the derivatives of both of these. So x to the 102nd, this is a integer power of x. We know how to do that. The 102 is going to come down, so I'm going to have 102 times x, and then the new power of x is going to be 1 less. So it's 102 times x to the 101. G prime of x, so this is a quadratic, so it's a sum of x to a power, so I can just do these one by one. Derivative of x squared is 2x, plus the derivative of 3x, well, the derivative of x is just 1, so there's going to be 3, and then the derivative of the constant gives me just 0. So g prime is really 2x plus 3. And so then, applying the chain rule is f prime of g of x times g prime of x. Well, now I can just plug things in. So f prime is 102 times, now I plug in g, x squared plus 3x plus 1. Finish my f prime by raising it to the 101st power. And then at the end, I got to multiply by g prime, which is 2x plus 3. Okay, so overall our derivative is 102 times x squared plus 3x plus 1, all raised to the 101st power, and then multiplied by 2x plus 3. And that's the chain rule. Thank you for watching. I will see you again soon.